In this video, we are going to be discussing inequalities, so how to show answers for inequalities. So an inequality is a statement that compares two quantities which are not equal to one another. So there are 5 different ways that we can compare this non-equalness with. So first we have the less than symbol, so this first one in red is our less than symbol. I never understood or enjoyed the alligator reference. I always think about it as a number line. So if I'm going to draw a line between these less than and greater than sign to show a number line. So how I always think about it is that the number on the left, so for instance we have 2 here, and let's say 3. The number on the left is to the left of 3 on the number line, so it's less than 3. So again, this arrow is pointing to the left, less, so that is telling me that 2 is less than 3. And the same with over here. So if I said 5 and 3, 5 is to the right of 3 on a number line, so this is the greater than sign. So 5 is greater than 3, so forth and so on. So we also have less than or equal to, or greater than or equal to. So we have the part of the equality sign, so we have the lower half of the equality sign underneath the less than or greater than sign to show that it could also be equal to, but not necessarily equal to whatever quantity it is talking about. So we have the less than symbol, we have the greater than symbol, and then we have the not equal to symbol. So we have an equal to with the slash through it, so it's just saying that these two quantities are not equal to each other in any way. So in math, we typically are looking at these quantities and we are comparing them with an unknown. So something that's not known is greater than something else that we do know, or less than, so forth and so on. So we need to be able to represent this with some kind of solution of an inequality. And that's basically going to be any number for that variable that makes it a true statement. So for instance, if I have x is greater than 3, one of the solutions could be x equals 4 because 4 is greater than 3. I could have also said x equals 5 because 5 is again greater than 3, so forth and so on. So as you can see, I actually have an infinite amount of solutions, because I could have, instead of saying 4, I could have said 4.5 or 4.55 or 4.555, so forth and so on. So there's an infinite amount of ways that are solutions to x is greater than 3. There's an infinite amount of numbers that x could be that are greater than 3. So because of that, we typically graph our answers for inequalities. So you've probably graphed inequalities in the past, so we're just going to talk about it again though. So notice that again we have these number lines, so we have number lines, and we're going to shade part of the number line depending on what we're looking at. So here we have x is less than, so we have less than, so x is less than 5. So over here I have my 5. So here is 5. And if you notice, I have an open circle here. The open circle is denoting that it's not going to equal this 5. This is almost like a boundary, a force field around this 5. You can get really close to it, but you can't actually be 5. So that's why it's an open circle. So anytime we have a less than sign or a greater than sign, we're going to see open circles at those numbers. So that's why on the first one we have an open circle at 5, and on the second one we have an open circle at -1. On the other two, when we have the or equal to, you notice that we have a filled in circle because we're saying, hey, it actually could equal that number as well. So that dot is basically putting a dot on the line saying this is an answer as well. So an open circle, when it doesn't equal it, a closed circle, meaning included, it is in the answer. So then, if you think about the way I was describing the less than or the greater than being to the left or being to the right, you can use that idea that all of our numbers of x are going to be to the left of 5 because I'm pointing my arrow to 5. If you notice here, so let me go over this again. My arrow is pointing to the left. So all the numbers to the left of 5 are going to be included to the answer. So that's why you see this shading to the left of 5, because every number less than 5 is part of the answer. And you can see it on the second one as well. We have x is greater than -1, so you can see that we have this arrow pointing to the right this time. And any number that is greater than that -1, so I'm going to the right of -1 for my answer. So if you want to use this idea of left and right with the less than or equal to, the important piece that you need to understand is that your x's need to be on the left side of your equation for you to be able to say that. If you had flipped this equation around, so instead of having x is less than 5, it would have looked like 5 is greater than x. So notice that I flipped everything, including the sign around, because 5 is going to be greater than that x, and x is less than 5. So I flipped it around, but now the arrow is pointing to the right, so it doesn't make sense by trying to graph it that way. So as long as you have your x on the right, it also makes sense to verbally say, you can say a number is less than 5. So any number less than 5. If I had flipped it and said 5 is greater than any number, that's kind of a weird thing to think about. But me saying any number is less than 5 allows me to know, hey, I just need to think of a number that's smaller than 5. So it's the same with all of the other ones. So you can see that we have this filled in circle for the or equal to pieces on the bottom two, and x is less than shows I'm going to the left for this solutions, and x is greater than the 0, I'm going to the right of 0. So any number greater than 0 is going to be an answer. So we just need to draw a number line and open circle or filled in circle at the number we're looking at, and then we need to shade to the left or to the right. If it's less than, so if x is less than that number, we shade to the left. If x is greater than that number, we shade to the right. So things that you are going to see a lot are the words no more than and at least. So no more than means less than or equal to. This is very important. So no more than is going to be your less than or equal to, while at least is going to be greater than or equal to. The way to think about it is that think about it with chicken nuggets. If you say, hey, I can eat no more than 5 chicken nuggets, well, let's be realistic. I can eat no more than 20 chicken nuggets. That means you can eat 20 chicken nuggets or anything less than 20, and you would be fine. So that's why we have the less than or equal to. We're telling us a max. So we're saying that no more than is our max number that we can eat, but we can eat anything less than it. The other, for at least, think about it for grades. So when you say, hey, I want to make at least a B this semester, that means you're saying, I want to make a B or an A. So you want anything that's greater than or equal to a B. So an A is greater than a B. So that's that greater than or equal to. So no more than chicken nuggets. I can't eat more than 20 chicken nuggets. That's my max. I can eat anything less than that. For at least, think about it for grades. I want a B or greater, or at least a B. So that means it's going to be more than a B. So anything greater than a B. So let's look at an example. So we have Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees. We're going to start by defining a variable, which means we just pick a variable and we define it by saying what it means, and write an inequality for the temperature at which he can turn on the air conditioner, and then graph the solutions. So I want to come up with a variable. So my first step is to define a variable. So anytime you have a word problem and you're working with variables, you want to come over to the side and say, hey, x equals or t equals or whatever. So I'm going to actually use t in this example because we're talking about temperature. So I'm going to say t equals the temperature when he can turn on the AC. So I defined my variable. This is me defining that variable. I said t equals something in words. So that is what it means to define something. Like when you're defining a word, you say what that word means in other words. So same with defining a variable. You pick what variable you want to use, and then you say in words what it represents. So now we want to go and we want to write an inequality for the temperature at which he can turn it on. So our variable t represents our temperature which he can turn it on. And Ray's dad says that it needs to be at least 85 degrees. So notice that we have it almost in a verbal, like the sentence itself is setting up the equation in a logical, chronological order. So first we have temperature. Well, there's my variable. Next we have the word at least. Well, we know that at least means anything greater than or equal to. So I'm going to put greater than or equal to because we just talked about what at least means. Greater than or equal to. And then we have the 85 degrees. So 85 degrees. So notice that it actually went in the order that it was written. Temperature is at least 85 degrees. So we have our T is greater than or equal to 85 degrees. So we just set up the inequality. So we did part 2 of this problem. So the first part, define the variable, which was T. We said what it actually equaled. Then we wrote an inequality. So now I just need to graph the solution. So I'm going to come over here and graph the solution. So I'm going to use a number line. I'm going to start this number line over here with 80. Here's 85. So I went by 5s. So there's the arrows on the left and right mean that it continues to the left and continues to the right. So there's no reason to have to start at 0 and then go all the way up to 85. So 0 is included in that left arrow. So I started close to my number, but I didn't want to start exactly at my number in case I needed to go to the left or whatever. So here I am. So I now need to choose whether it's going to be an open or a closed circle. So the fact that I have this or equal to piece tells me that it's going to be closed. So I'm going to close my circle at 85. We say that t has to be greater than or equal to 85, so that means any number that is greater than 85. And notice how my arrow is pointing to the right, so I just need to go and shade things to the right. So I'm going to come and shade to the right. And that's it. That's done. I answered all parts. I defined my variable. I said what it was in words. I then wrote the inequality. So I basically changed their words into a mathematical equation or inequality in this case. And then I graphed the solutions. So I made a number line. I decided whether it was closed or open, shaded left or right. So here is one for you to try. So again, you are defining the variable. So the variable I may pick may be different than yours, but that's okay. As long as you define it and you say what it is and the definition is the exact same as mine, you're good. So I picked the variable smiley face to kind of show you that it doesn't matter what it is as long as you defined it. And I said smiley face equals the money made per hour. So it's the amount the employees can make per hour. And my inequality was smiley face is greater than or equal to $8.50. And on my number line, I had 850 shaded, so the circle was closed, and I shaded to the right.